Hello guys, welcome to Solving Solutions on Balance channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you how to extract the properties of these different map sheets, or let's say one of the map sheets in this what index map, right? Good. Now, this data was provided by Dr. GT Purple of the Surveying and Geomatics department at the Rivers State University. I want to especially appreciate him for his assistance in providing us data for research purposes, right? Good. Now we have this map, and then the scale is 1 in 48,000, right? Good. Now the units of the coordinates on this map, which you can see, we can see the eastern coordinates somewhere around here, and then we can see their corresponding northern coordinates, right? Good. Now the units on this map is actually in feet, right? Good. So these are some salient points you need to remember. We've talked about the index, it being an index map. We can see the numbers on what each of the what rectangles, right? Good. That can help us identify which number what each of the maps can be extracted, right? Good. The index numbers, right? Good. Now we have also seen what the coordinates, right? Good. And then we have also told you that the units of these coordinates are in feet, which means if we are going to work with it now, first off we need to convert them to meters. Then finally, the CRS, let's say the projection or the origin, is actually what in NNO, right? Good. Mid belt. So these are some important information that we need to have in mind before we proceed. So we are interested in what sheet 3872, right? Good. We are interested in sheet 3872. So for us to extract this sheet 3872 from this old map, we need to identify the coordinates of these four edges, right? Good. I think I should just zoom in a bit. We need to identify the coordinates of these four edges that bound 3842. So the first thing is that if you look at it very closely, on this what horizontal line, we have the coordinates of what 280,000, right? Good. So if it's not clear at this point, you can actually see it at this point. We have what 280,000, right? Good. So we are going to call it what point A, point B, point C, and point D, right? Good. Going in the clockwise direction. So if this is what point A, that means the northings of this point is what 280,000, right? With that, so we have 280,000 northings. They have been extracted somewhere. We are going to show them to you very soon. Then if we also want to look at the eastern, remember it's on this first line as well. And then the eastern coordinate of this first line is what 1,638,000, right? Good. Remember the units is feet, or the unit is in feet, right? Good. So we have what 1,638,000. Now the next thing is for us to know the constant with which what it increases in the horizontal and then the vertical and the horizontal, right? Good. Now if you look closely, we have what 272,000, and then we have 280,000, right? Good. So if you get a calculator, we have 280,000 divided by 272,000, right? Good. So we are going to see a difference of about 8,000, which means on the northern axis it goes from 272,000 to 280,000. So if we add that to 280, we have what 288, which is this point. If we add another 8,000, we have what 296, which is this. If we add another 8,000, we have what 304, which means the northern axis, the northern coordinates are increasing by what 8,000 feet. Pay attention to that. Similarly, we can identify the magnitude at which what the eastern coordinates also increases, right? Good. So we have 1,638,000, and then we have what 1,650,000, right? Good. So the next thing is for us to find the difference between the successive values. So we have 1,650,000, 000 minus 163,800. So we're having about 12,000 feet, right? Good. So it increases by 12,000 feet in the what, in the eastern axis, right? Good. So the eastern is what, the x, then the northern is what, the y, right? Good. So please pay attention to this part. So we have what, 163,800 plus 12,000. So we have what, 165,000 plus another 12,000 again. Remember that's in feet. We have what, 166,200 plus 12,000. We have 167,400. So these are important facts to what to note. So on the northern axis, it increases by what, 8,000 feet. Then on the eastern axis, that's this axis, it increases by 8,000 feet. Then on this axis, it increases by what, 12,000 feet, right? Good. So what is our interest? Our interest is what, this sheet 3872. So we have identified that point A, which is this, has what, a northern coordinate of 280,000 feet, and then the eastern correspondence is what, 163,800, right? But that's for the what, for the eastern. So we need this other point, right? Good, because it's still part of the boundary of what, 3872. So for this other point, we can still see that it is still the same what, northern, right? Good. So for our B, our northern is what, 280,000 feet. Then the eastern this time around is now this second line. So it is now what, 1,650,000 feet, right? But please pay attention to that. Remember, we've told you by how much it increases on the eastern axis, or let's say the x-axis, and then by how much it increases on what, the northern axis, right? But that's the y, right? Good. So we have identified point D to be those values of 280,000 feet and then 1,650,000 feet for the eastern, right? So if we move down, please, these things are very, very important. When we move down to point C, which is this point, remember we are going clockwise. So we'll move down to point C, which is this one. We are now going to see that we have what, a different northern value. We have left this 280. We are now on what, 272. So our northern value for point C, which is on this line, is what, 272, because of this 272, right? Good. However, our eastern value is still the same line, starting from this top, right? Good. So our eastern value is still what, 1,650,000 feet. Finally, we come down to point D, right? But that's the last point that bounds, or yeah, that bounds our sheet. So we have what, the northern to be what, 272,000, and then the eastern to be what, the eastern we started with, which is what, 1,638,000 feet, right? So this is how you extract the coordinate. Please, if you missed it at any point, you can always pause the video, rewind, and then maybe you get the explanation. So having extracted these coordinates, let's now move to Excel where we have written them down. Good. So as we say, for sheet 3872, we have what, we gave it 1 2 3 4. You can actually replace it by what, A B C D. So we have for the eastern we have 163,800, for the northern we have 280,000. So these are what, the coordinates as we have extracted from what, the sheet, right? Good. The next thing is for us to convert these values in feet to their corresponding meter values, right? Good. To their corresponding values in meters, right? Good. There's a constant for conversion. The constant for conversion is what, 0.3048, right? Good. So if you have a value in feet and then you want to convert it to meter, you just multiply that value by what, 0.3048. So what do I mean? So let's just pick a new cell equal to, so we have what, this value in feet multiplied by 0.3048, right? But that's a constant. So we have this. So this is what the eastern corresponding coordinate of this particular point. We can decide to autofill. You can see that we are having the same values that we had here, and then we can also decide to drag it to this other what, the northern axis, and then let's increase the decimals to 3 decimal places. So you can now see that we have the same value. So that's how we converted this value in feet to these values in meter. And then remember that we still have what our NNO here, which means that that is what the CRS that we are going to use when we want to plot it, right? Good. So please follow through how we got to this point. We have extracted the coordinates, we have identified them to be in feet, we know that it's in NNO mid belt, right? Good. Then we have converted these coordinates in feet to their corresponding values in meters, which we have done here. Then we have also demonstrating it using these other cells in the spreadsheet here. The next thing is for us to copy this eastern and northern, then overlay it, or maybe overlay it on the base map in GIS, which we are going to use QGIS on today's tutorial. So we are going to import these our points to QGIS. Here we go. So we have extracted them. We have the eastern and the northern. So let's open QGIS. So the shortcut is Control Shift T. That's to import delimited text values. So delimited text, right? Good. So we browse. So we have 3872. We open that up. Now we can see the X for eastern, the Y for northern in meters, right? Good. Then for the CRS, we are using the mid belt. So we've actually selected that MENA Nigeria mid belt, right? Good. So you can search for it. Maybe you type MENA somewhere around there, then you can see what the different results that comes up. Then you select what the mid belt, right? Good. So we click on OK. So having established all of these facts, which means our coordinates are in meters and they are actually in the right CRS, right? Good. So we add. Okay, we are using this first option. So let's also bring in a base map, like OpenStreetMap, right? Good. So we okay, and then we close. Bring that down a bit. If this does not do it, we can still come down to web, quick map services, Google. Then let's use Google Library, right? Good. So we have the points overlaid on Google Map. Good. So when you zoom in, you can see some of the features that fall within that particular map sheet. So if it's something that you want to map out from the scratch, you can know the way you start your mapping, right? So as we have seen earlier, this is sheet 3872. There are other sheets here. We have 5080, 5088, 5096. We have 5004. We have 6204. So if you have extracted any of these sheets and then maybe done the necessary conversion to get the corresponding coordinates in meters, and then maybe importing it to your GIS, you would definitely see it being overlaid anywhere in this river state, or maybe anywhere in river state on your maybe Google Earth or any other base map you have. So thanks for coming to class. We have shown you on today's tutorial how to generate or gain insight from maybe an old map like this, identifying the coordinates, knowing that the units are in feet, and then understanding, right? Good. Understanding the increments on the X and the Y axis, so that you know what to add to get successive coordinates, right? Good. So having understood that, you can now extract coordinates of each intersection, right? Good. Extract coordinates of each intersection. Then having a spreadsheet like this that helps you convert those coordinates that are in feet to meters, and finally importing them toward a GIS package, which we are using QGIS on today's tutorial. So thanks for coming to class. we are going to see you on our next video. If you have any challenge, if you have any tasks like this that you would want us to do for you, you can always reach out to us and we'll get back to you as soon as possible. So until we see you on the next tutorial, ensure you keep staying safe and have a very good time. Bye.